1.3 Algebraic expressions. So what we're looking at here is how to write an expression from words to math. So the words like fewer, more than, at least, at most, things like that are things you struggle with. So it's something we need to definitely take a look at. And in this one here, it says, which algebraic expression models the word phrase 7 fewer than the number t? Well, obviously fewer, we're talking about subtraction. So we're looking at C and D. Which one is 7 fewer than the number t? And they mess you up by putting the number 7 first and then following up with the number t. So they want you to lean towards D here a little bit. But when you're talking about 7 fewer than number t, you're talking about, okay, that person has 7 fewer than me. That takes my number of whatever we're talking about, minus 7. So my correct answer here is going to be C. Okay, you start with $20 and save $6 each week. What algebraic expression models the total amount you save? So what you want to really do is kind of start talking about variables. So we're talking about each week, so let's use the letter W to represent week. Okay, so if you start with $20, and I like T for total, that doesn't matter what you use there, but if you start with $20 and you save $6 each week, so you're going to add $6 to that times each week, which is just W. So my total is going to be 20 plus 6W. Problem 3 talks about evaluating algebraic expressions. So what is the value of the expression for the given values of the variables? So if we're looking at this, it's 7 times a plus 4 plus 3b minus 8. For a equals negative 4 and b equals 5. So all we're going to do is we're going to substitute those numbers in where they go into the problem. And I technically have a issue with things of, like, I always make sure I substitute in parentheses. So if I'm doing this, and it's going to look a little weird at first, but 7, then a equals negative 4, but we already have parentheses there. There's nothing wrong with throwing it still in parentheses because it kind of takes care of operations and things that you might see. Plus 4, plus 3, then b, multiplication is assumed, but I'm going to substitute it in a set of parentheses, minus 8. Remember to use order of operations as we solve here. So negative 4 plus 4, because it's in the parentheses first, that gives me 7 times 0 plus 3 times 5 minus 8. So then we're going to go in order left to right because we're talking about multiplication first. 7 times 0 is 0 plus 3 times 5, which is 15, minus 8. And then left to right again because now we're talking about addition and subtraction. You work left to right. 15 minus 8 gives me a total answer of 7. This problem kind of brings all the other problems together that we're talking about. So it says in football, a touchdown TD is worth 6 points, an extra point kick 1 point, and a field goal 3 points. What algebraic expression models the total number of points that a football team scores in a game, assuming each score in play is one of the 3 given types? Suppose a football team scores 3 touchdowns, 2 extra points, and 4 field goals. How many points does the team score? Well, if we call touchdowns T, stands for TDs. Extra points, we'll use K, that's fine, it doesn't matter, for extra points. And we'll use F for field goals. If they scored 3 touchdowns, so 3T, 2 extra point kicks, so plus 2 Ks, and 4 field goals plus 4F, how many points does he equals total points? So we'll call that P. What you're going to end up doing is substituting the values in for those letters. So if a TD is worth 6 points, it's 3 times 6, plus an extra point, which is worth 1 point, plus a field goal, which is worth 3 points. That's going to equal your total points. Again, working left to right for the multiplication first, you get 18. Don't do the addition yet. 2 times 1 is 2. 4 times 3 is 12. Add them all up. You get 32 points. These are all your properties of simplifying algebraic expressions. I can give or take these things. It's not a bad idea to have them down, But as far as understanding, kind of knowing what it is, if you know how to solve a problem, it's pretty much what they're talking about here. So we're looking here about combining like terms, and this is something that students have always traditionally struggled with because dealing with things that don't have a tangible value to it seem to be an issue. But here, you're just simplifying the algebraic expressions. And combine like terms, what is the simpler form of each expression? Now, like terms are always same variable raised to the same power. That's what we define like terms as. So if we look at the x squared and the x squared, I can combine that. 7x squared minus 4x squared is 3x squared. 3y squared and 2y squared, because they're both y squared, I can combine them. 3 plus 2 is 5y squared. Now, since that has an x, that one has a y, there's nothing I can do, and we are finished.